Assalamu alaikum. Good evening, dear honorable speaker, research enthusiast participants. Welcome to our most expected research idea series. I am Sultan Mahmud, campus research co-ambassador of ℮𝒶𝓇𝒾ℯ𝓈, ℮𝒂 platform from Khulna University of Engineering and Technology, KUET. It's my pleasure to host today's program. Before dive into the live session, I will introduce ℮𝒂 platform, its mission, vision, and activities. ℮𝒂 is an online-based non-profit open platform directed by some world-class scholars. We are tirelessly working to promote research and guide young researchers in Bangladesh. Its vision is to leverage research in higher education institutes for sustainable development all over the world. This noble effort has been initiated by Mr. Mohammad Sabir Hossain. He is working as an assistant professor at the Department of Computer Science and Engineering (CSE) of Chittagong University of Engineering and Technology, KUET, Bangladesh. Universities are the place for knowledge creation and dissemination. However, we know that the universities are growing in the traditional way. Although the final year students do their thesis or project for obtaining the certificate, but research and publication at undergraduate level are rare. Mr. Sabir Hossain worked in a different way. By his effort, the second year students of the CSE department of KUET have published more than 10 articles in international conferences and journals. This type of accomplishment is rare, not only in Bangladesh, but also in first world universities. Being perplexed by these achievements, he has created this platform to diverge this enthusiasm among all the students who are interested in higher studies. We assist researchers by sharing research-related resources such as books, papers, websites, etc., conducting online or offline training or courses, arranging seminars, workshops, or webinars, research collaboration or supervision, arranging internship opportunities. Previously, we have conducted the country's first free complete online training on how to become a researcher. This course covers the basic concepts, tools, and techniques required to become a researcher from zero knowledge. The recorded lectures on YouTube received more than 39K views within 10 months only. Then we have started the most demanding online free course titled Python for Research for any discipline on 31st April 2021. We know that selecting research ideas is the most important step in research methodology. However, finding a research idea or topic is a challenging job for the research enthusiasts and new learners. To assist them in finding ideas easily, we are organizing this research idea series. Research scholars from home and abroad of different disciplines will deliver lectures related to his expertise or domain knowledge. Basically, speakers will share trending research topics, skills, tools, and techniques required to start his or her current and past research projects, publications, guidelines for a specific field. We have a plan to cover all possible research areas in future. Now, I am going to introduce today's session and speaker. It is the 13th lecture of the Research Idea series titled as Recent Emerging Metal Oxide Nanomaterials for Wastewater Treatment. The key highlights of this lecture are research areas in environmental science, wastewater management and data modeling, trending research in environmental science, skills, tools and techniques to start research in adsorption and data modeling, speakers' past and current research projects, reputed journals and conferences, publication tips, research collaboration opportunities. Today's honorable speaker is Assistant Professor Dr. Muhammad Aminul Islam. Sir, Dr. Islam completed his PhD in chemistry from La Trobe University, Melbourne, Australia. He got a highly competitive Australian government scholarship to pursue his doctoral study. Prior to this, he did BS and MS in physical chemistry from University of Dhaka, Bangladesh, and MPhil from KUET, Bangladesh. Currently, he is serving as Assistant Professor of Chemistry in Ahsanullah University of Science and Technology, AUST, Dhaka, Bangladesh. The lecture will start now. There will be a question and answering session after the lecture. You can ask your questions by commenting on this live program on our page. Now, I am requesting our honorable speaker to start today's lecture. Sir. Sir, please start your lecture. স্যার, আমার কথা শুনতে পাচ্ছেন স্যার?
So now may I share it?
Please, sir, please share.
Okay. Okay. Okay, can you hear me?
Yes, sir, I can hear you, sir.
Okay, thank you so much for your nice introduction. And in the beginning, I would like to thank organizer, BD researcher, and ℒ𝒶𝓇𝒾ℯ𝓈 for giving me the opportunity to present my research here. Honorable host, co-host, and dear viewers, this presentation is a part of my PhD thesis, which has been carried out at ℒ𝒟𝒃 University, Melbourne, Australia. Today, I would like to talk on recent emerging metal oxide nanomaterials for wastewater treatment. Now, I will talk a background of my research. Well, trending research in environmental sciences. Wastewater treatment is the most discussed topic in recent years due to rapid urbanization, industrial revolution, and overpopulation growth. Huge volumes of wastewater is generated. This wastewater primarily contains heavy metal ions, organic dyes, phosphates, natural organic matters, medical waste, and other substances. So these pollutants are creating serious problem to our aquatic system. So now I will talk why metal ions removal. Well, the major pollutants of aquatic environment is heavy metal ions and contamination of heavy metals, for example, cobalt, nickel, chromium, posing a huge threat to our ecological environment. And this problem is being acute day by day, especially for country like Bangladesh. And exposure to high levels of metal ions can cause severe health problems, including vomiting, asthma, pneumonia, and cancer. And it is also suggested that a significant level of metal ions in the soil can be also cause acute toxicity to the plant kingdom. So it is very essential to remove these pollutants from aquatic environment. Then comes why phosphate removal. As we know, phosphate is a typical macronutrient for plant growth and development in soil. However, excess phosphate originated from fertilizers and other sources can create a serious problem for aquatic environment. And excess phosphate in aquatic environment can produce algal growth, which can reduce the amount of dissolved oxygen in aquatic system, which is known as eutrophication. This causes reduction of reduction of dissolved oxygen and ultimately kills aquatic life such as fish and other animals and disrupt natural food chain. So it is important to remove excess phosphate from aquatic environment. Then comes natural organic matter. Although natural organic matters are important for environment, however, presence of excessive humic acid in aquatic environment threatens both aquatic life and human health. And presence of humic acid in waterways causes undesirable color, nasty odor, and taste. And they also produce hazardous disinfectant byproducts and can reduce the amount of dissolved oxygen in aquatic environment. And it has a strong affinity for metal ions, pesticides, herbicides, and thus it is able to enter the human food chain. And high intake can cause cancer, black foot, joint, circulatory, thyroid diseases, and affect human reproductive system. So it is mandatory to remove excess humic acid from wastewater. Then also we need to remove organic dyes, which are usually originated from textile mills and other industries. Now the question is, how can we remove these pollutants? Well, it's simple using metal oxide nanomaterials. Here I have shown a picture where it shows the composition of soil. Soil is a complex mixture of mineral particles, organic matter, natural organic matters, water, and air. And metal oxides are a typical component of soils. Here I have shown oxides of iron, aluminium, manganese, and other minerals. And iron and aluminium are the most frequently obtainable metals, and manganese is third available nanomaterials. And our research group dealing with iron and aluminium oxide over 20 years, I have introduced metal oxide nanomaterials probably for the first time in Australia. And it is interesting to share that these metal oxides nanomaterials have special properties. For example, they have high surface area and low to moderate specific surface charge and mesoporous structure. These properties enable them to absorb heavy metal ions, aromatic compounds, volatile organic compounds, pesticides, dyes from water. Then I have used manganese oxide nanoparticles, but why? Well, manganese is the most wonderful element in the periodic table, and it comprises 0.1% of the earth crust. And manganese is a component of more than 100 minerals of phosphates, sulfides, oxide, carbonates, silicates, and borates. And it has been found that heavy metal have strong affinity for oxides compared to iron and aluminium oxide. And very little attention is paid to the environmentally important manganese oxide. And we don't know how various pollutants and contaminants interact with manganese oxide. So, This study is very important using manganese oxide for wastewater treatment. Okay, now I'll talk a brief background of manganese oxide. For example, sources. There are mainly two types of manganese oxide sources. One is natural and another is anthropogenic. Natural sources include oxide, silicate, carbonate, phosphate, borate. And on the other hand, anthropogenic sources include wastewater discharges, mining, mineral processing, and here I have shown the sources of manganese oxide minerals in percentage, and it is found that 15% manganese oxide ores are produced by Australia, and China produces 31%, and that South Africa produces 16%. Then comes polymorphs. As I said, manganese is the most wonderful element in the periodic table, and especially due to various oxidation state. And due to various oxidation state, several polymorphs of manganese oxides are claimed. Here is the list of several manganese oxides. But our interest was to use barnesite, pyrolusite, osmanite, and manganite because these four types of manganese oxide comprise all composition of manganese, and these are commonly available in soil environment. Well, then comes structure, and one of the most important feature of manganese oxide minerals are structure. The basic component is MnO6 octahedra, and there are three types of structure. One is phyllomanganates, second is tectomanganates, is spinel-like structure. And it is important to see that for barnesite there is interlayer spacing, which enable them to absorb uh, heavy metal ions or other metal ions. So we can easily use these manganese oxide minerals for wastewater treatment. Now, research area in environmental sciences and wastewater treatment. Well, there are several physical and chemical methods have been implemented for wastewater treatment, but for example, adsorption, membrane technology, coagulation, flocculation, precipitation, ion exchange, biological methods. But adsorption is the most common for pollutants removal and is much more convenient, requires less investment, and is effective at low concentrations. And we can easily use adsorption process to remove pollutants from aquatic environment. And bioavailability, mobility, fate, and transport of pollutants are closely related to its adsorption and desorption reactions. So, it is very important to use adsorption methods. Now, why competitive adsorption? Well, multiple pollutants are found in wastewater, so presence of one pollutants can interfere the absorption behavior of other pollutants. However, this complex system can be described properly if competitive reactions or processes are considered. So it is worthwhile to study competitive adsorption process. Well, then comes adsorption experiments. Adsorption experiments are done by two methods. One is batch adsorption, another is continuous mode adsorption. I have used here continuous mode adsorption, where the pollutants and suspensions are in the reaction vessel for the entire period of study. And to understand adsorption behavior, Usually, we carried out adsorption kinetics, adsorption ages, adsorption isotherms. Well, here I have shown a typical example of cobalt adsorption kinetics onto barnesite, boehmite, and manganese aluminum binary oxide. So, from this figure, we see that adsorption of cobalt onto these nanomaterials are rapid and reached equilibrium within 15 minutes. Therefore, we can say that we can use this technique for real environmental sample removal. Well, then comes adsorption data modeling. Well, to understand the adsorption mechanism, we need to do some modelings. For example, adsorption kinetic model, adsorption isotherm model, adsorption surface complexation model. So here I have shown various types of adsorption kinetic model to understand adsorption process. For example, two parameters model, CO2 first order, CO2 second order, intraparticle diffusion, LOVs, Boyd model, Banga model. However, there is also some models with three parameters. These are Abrahami model and double exponential model. So it is interesting to mention here that all kinetic models fitting can be found at my YouTube channel Aminul Islam Innovation. Here is the link. Then comes adsorption isotherm models. Well, adsorption isotherm models are very important to find out the maximum surface coverage. For example, we usually use Langmuir model to find out the maximum adsorption capacity under experimental conditions. So here I have list some adsorption isotherm models. So and all models fitting can be found in my YouTube channel Aminul Islam Innovation. Then comes surface complexation model. Well, surface complexation model is a powerful tool to understand how pollutants bind to the surface in aquatic system. So there are four types of surface complexation models we usually use. For example, constant capacitance model, extended constant capacitance model, diffuse layer model, and triple layer models. For example, I have shown here extended constant capacitance model, which is based on Stern triple layer model, has two adsorption planes. Strongly bound ions adsorb at the surface plane or zero plane, whereas loosely bound ions adsorb in an outer plane or beta plane. And it is important to note here that this ECCM model can predict both uh, inner and outer sphere complexation and requires less parameters than triple layer models. However, it has disadvantages too. For example, other layers, for example, delta and diffusion, are not defined in this CCM. Well, then skills, tools, and techniques to start research in adsorption. Well, to start research or to use any substance as adsorbent, we must know the surface properties of these adsorbents or nanomaterials. So, surface properties are easily identified using XRD, scanning electron microscope, energy dispersive, micromeritics, ASAP bed surface analyzer, surface charts by dynamic light scattering, which can identify zeta potential, and attenuated total reflectance Fourier transform infrared ATR-FTIR and X-ray photoelectron spectroscopy. However, we can also study adsorption with UV visible spectrophotometer, atomic absorption spectrophotometry, ICP-MS, ATR-FTIR, DLS-XPS to understand the actual surface phenomena. Well, then we also use some softwares to graph adsorption data and to model adsorption data. The most frequently used softwares are Origin Pro and Excel. However, using wind, salt, gas, water, we can easily model surface complexation model to understand the actual adsorption phenomena onto the surface. Okay, next comes here I have shown adsorption data modeling for cobalt adsorption. Here I have shown Langmuir adsorption. So, and then here is the fitting of adsorption data using Origin Pro, and details can be found in my YouTube channel Aminul Islam Innovation. Then here I have shown the Langmuir parameters for cobalt adsorption at pH 8.5. And it is interesting to note that K values are relatively larger, which implies that cobalt strongly bound to the surface. Well, then comes adsorption mechanism. Well, it is very essential to understand adsorption mechanism during pollutants removal from aquatic environment. Well, adsorption mechanism is primarily explained in terms of inner sphere complexation and outer sphere complexation. So, in case of inner sphere complexation, no water molecule is present between adsorbate and surface. On the other hand, in case of outer sphere complexation, at least one water molecule present between adsorbate and surface. Usually, for metal ion removal at low pH, outer sphere complexation is formed and inner sphere complexation is formed at higher pH values. And the situation becomes reverse for anionic pollutants removal. Well, then past and present research project. Well, I did BS, MS, MPhil, and PhD. So my past project was preparation of colloidal manganese oxide, and also I prepared colloidal manganese oxide nanomaterials and applied them to remove organic dye, for example, methylene blue, orange green from wastewater. And in my PhD, I also used competitive adsorption of metal ions, for example, cobalt, nickel, chromium, and humic acid using various metal oxide nanomaterials. And currently, I am also working on the use of tea waste and paper waste for pollutant removal, because these are low cost adsorbents and locally available. So this could be also interesting for wastewater treatment using these low cost tea waste and paper waste materials. Then comes reported journals and conferences. Well, so far I have published more than 20 articles in reported international journals. So these include separation and purification technology, whose impact factor is 7.312 and site score is 9.9. Journal of Water Process Engineering, impact factor is 5.48. and Journal of Environmental Chemical Engineering, impact factor 5.9. And I have also published several other journals, for example, Microchemical Journal, Environmental Nanotechnology Monitoring and Management, Journal of Molecular Liquids, Environmental Science, Water Research and Technology, Arabian Journal of Geosciences, KUET Journal, and some other journals. And I have also participated more than 20 national and international conferences. These are the example of some conferences. For example, Bangladesh Chemical Society conferences and International Conference on Science and Technology for celebrating the birth centenary of Bangabandhu. And here is the list of some other conferences. And it is mentionable that I also participated Royal Society of Chemistry, Worcester, which is Twitter conferences several times. And for the first time, I was scored good. And then I also participated 3 minute thesis, which is very popular event in Australia, which is you need to present your thesis within 3 minutes. And fortunately, after presenting this, I became winner of the school hit round. And this can be also popular for Bangladesh as well. Then the detailed list of my publications are available in my Google Scholar profile or ResearchGate profile. And then publication tips. Well, every researcher need to publish. Without publishing, data has no value. So during my PhD, my primary goal was to collect data. So I thought that if I collect data, then I will be able to publish uh, this one day. So after collecting and finishing, my supervisor told me that you have collected data which can be for 3 PhD students. So for this, I have publishing various articles, and still there are more than 20 manuscripts on hand. I will be publishing in near futures. And publication tips. Well, I have given some publication tips to my YouTube channel. Interested viewers can watch this. And then research collaboration opportunities. Well, it is very essential for every researcher. So I am trying to collaborate my research with Lathrop University, RMIT University, Australia, and University 𝒠𝒃𝓃 Morocco, and Noakhali Science and Technology University, and Japan Atomic Energy Agency. So from this collaboration, I have already published several articles, and there are also some manuscript which will be published in near futures. So I welcome every researcher to contact me for any collaboration. My door is always open. And finally, as I said before, I have opened a YouTube channel, Aminul Islam. These are very essential for every researcher. So I request every viewers to visit my channel to learn on education, research, innovation, and its primary goal is knowledge sharing. So all of you are welcome to visit my channel, and please do watch video and subscribe to my channel. And thank you so much for your kind attention.
Thank you, sir, for your wonderful and motivating speech. Hope that it will be helpful for all the participants. Now, I will read out questions from the comment box.
Sure.
So I'm facing some technical issues. I will request for a few minutes.
I request everybody to ask anything.
So here,
Sure.
Naim Riaz has asked, Sir, would you give some advice to young researchers who started their research on wastewater management?
Oh, it's very interesting question. So I would like to suggest that for wastewater treatment you need to select some adsorbent. It could be natural adsorbent or synthesis adsorbent. For example, you can use metal oxide nanoparticles or some other types of adsorbents. For example, agricultural derived adsorbents or zeolites or other types of adsorbents. So in the beginning, you need to characterize the adsorbents that you have selected. Especially, you need three things. For example, you need specific surface area, then you need point of zero source, then you can take X-ray diffraction study. So after this study, you can start your adsorption process, that is wastewater treatment. For example, you select easiest thing. For example, you can start with adsorption of methylene blue onto uh, tea waste or paper waste. So these are easier using this requires only UV visible spectrophotometry. So you can gather data for adsorption kinetics, that is effect of contact time, then effect of solution pH, then effect of initial pollutant concentration. Then you can also study um, effect of adsorbent juices on adsorption. Thank you so much again for this question.
Sir, thanks again for your valuable time. Also, thanks to the audience for your participation. Our next Research Idea Series 14 will be held soon. To get updates of our activities, follow our page, join our group, and subscribe to our YouTube channel. We're happy to inform you that we are now a family of nearly 30K members. Sir, here is a comment from our initiator, Mohammad Sabir Hussain sir. Can I read it, sir?
Yeah, sure.
Sir has said, thanks a lot for your time from busy schedule. Hope young researcher will be benefited from this lecture.
Thank you so much for your appreciation. I visited Gobeshak Hotesai YouTube channel several many times, and these videos are really appreciable. And I think young researchers will be benefited greatly watching videos from Gobeshak Hotesai. So I recommend young researchers to watch videos published in Gobeshwar Bhattacharya and subscribe that channel so that you can learn a lot of things from this channel. Thank you.
Thanks again, sir. Uh, our next Research Idea Series 14 will be held soon. To get updates of our activities, follow our page, join our group, and subscribe to our YouTube channel. We're happy to inform you that we are now a family of nearly 30K members, including groups, pages, channels, and LinkedIn pages in a very short time. Stay with Gobeshwar Bhattacharya Be Researcher BD and invite your research enthusiast friends to our platform. Thank you for being with us. Wish you all success and good health. Goodbye.
Okay, thank you so much. Goodbye.